All right, party people, this morning we'll be looking at Leetcode 88, Merge Sorted Array. In this problem, we have a couple of arrays, nums1 and nums2, both sorted in non-decreasing order. We're also given two integer values, m and n, which represent the count of digits in nums1 and nums2 that are to be sorted. We're going to keep track of nums1 and nums2 at m and n, but see how n is effectively the length of nums2? We need to do n minus 1 and m minus 1 to actually get the index of the final integer to be sorted in each array. To solve this one, we just have a few questions we need to ask. Is n less than 0? Is nums1 at index m greater than nums2 at index n? And is m greater than -1? Okay, so let's take a look at what we got going on here. We have our nums1 array, and at the end we have these zeros that are just placeholders such that we have room to merge the remaining values that are in nums2. Okay, so just kind of ignore those zeros. Like if we're writing in Python, they would be none, right? They wouldn't be actual zeros. They're not zeros. They're not getting sorted. Just ignore them, okay? Just think about it like the speed limit. Ignore it. You'll be fine. Don't worry. No consequences, right? Okay, so we're actually going to iterate through this backwards, and I hope that'll make sense as we go through it. If not, I'll explain it a little bit more when we actually write the code in the IDE. So we're starting at index 5 in nums1 and index, wow, brain fart. So let me write down one more thing here. We're actually going to have a pointer. We're going to call it our right pointer, as in WRITE, right? Because that's where we're going to write our new value. So 0, 1, 2, 3, 4, 5. It's actually going to be the length of nums1. I'll write that out. Length of nums1 minus 1, which equals 5. Okay, so we've got our two pointers, m and n, that are pointing to the final integer of each array that we're going to need to sort. And then the right pointer, which points to this placeholder over here. That's why it's called the right pointer. We're going to write things there. So let's do our comparisons. Let's ask our questions here, okay? Is n less than 0? Well, no, it's not. Is m greater than -1? Well, yes, it is. Okay. Is 3 greater than 6? No, it is not. Well, then we're going to put our 6 here. Let's just go ahead and move the 0, put the 6 there. Now, we're going to now have to decrement. Oh man, I got to get some more tiles. Shoot, I am totally unprepared. So let's grab a 2 and a... Okay, I've eaten some bacon, so I think now my brain is working such that we can walk through this algorithm. So like I said, we're going to start our iteration as follows. We have a pointer in nums1 that points to the final integer value to be sorted. We have a pointer for nums2 that likewise points to the final integer value to be sorted. We're keeping track of those values right here just for the walkthrough. We're not actually going to have a variable to store these values in the code. This is just for us to see them a little bit easier. And then we have our right pointer that is pointing to the final index in nums1. And that's where we're going to write basically our largest value each time, because this is sorted in non-decreasing order, and we're just going to merge them. So let's walk through the algorithm. So we have our pointers. We're going to check, is n out of bounds? N is 2, so n is not out of bounds. Is m out of bounds? No, it is not. Okay, so which one is bigger, 3 or 6? 6. Well, that's the one that gets merged. So we're going to put our 6 here. And because we wrote at the right pointer, we're going to decrement the right pointer. And I do not have a tile for that, so let's grab one. So the right pointer has been decremented. We use the value at pointer n, so that likewise must be decremented. So now we're pointing at index 1 of nums2. So let's go ahead and update the value here. Okay, everything's been updated. We're going to go ahead and merge the next index. Okay, is n out of bounds? No. Is m out of bounds? No. Is 3 bigger than 5? No, it is not. So we're going to go ahead and merge our 5. Take that out of there. Put that in. We wrote here, so the right pointer needs to be decremented. We used n, so that needs to be decremented. So now we're at index 0, and the value at index 0 is 2. Okay, so if you can't tell, this is simulating our for loop or a while loop. Kind of depends how we're going to do it. I think we'll use a for loop. So we're now to the next iteration. So are m and n in bounds? Yes, they are. Okay, what is greater? Nums1 at m or nums2 at n? Well, nums1 is. Okay, so let's go ahead and move that out. Move this in. We wrote at the right pointer, so we have to decrement that. We used this value, so m must be decremented. And what's the value at index 1? It's 2. Hey, we have a 2 tile. Boom, let's put that in there. All right, now we're at the next iteration. So are m and n in bounds? Yes, they are. Okay, now this is the first time we've come to this case. Is nums1 greater than nums2? Well, no, it is not. And I'll explain it in the code, but we're going to default to using nums2 for this one. So the right pointer is at index 2. Move that out of there. We're going to replace it with this value. Since we wrote, we have to decrement our right pointer. I need to grab a 1 tile. And we wrote with the n pointer. So this actually now, let's go ahead and write in a little negative here. This is now out of bounds. That index is now out of bounds. Keep that in mind. So we don't update this value because there is no value anymore. All right. So the right pointer, oh, did we already replace that? Yeah, we did. Okay. So here's the deal. Once n is out of bounds, we're done. We're done. Okay. So our original arrays were 1, 2, 3. And 2, 5, 6. Now we have 1, 2, 3, 2, 5, 6. They have been merged. They maintain their non-decreasing order. And we're going to head over to the IDE to code this up. Okay, so let's go ahead and code this bad boy up. So as discussed, we are going to iterate from the end of nums1 to the beginning. And in the past, I've done this in the for loop. But you know what? YOLO. Let's do a while loop, okay? So what are we going to do? We're going to say while, let's say while right pointer is greater than -1, right? Because we can't write out of bounds. At least, I don't think we should. I think that would be less than ideal. So right pointer, we're going to start at the length of nums1 minus 1, okay? All right, so what are we going to do? What did we talk about? Well, first we're going to check if our pointer at nums2 is out of bounds. So I'm going to write something and then we're going to change something. So if, what is the pointer for nums2? That's n. So if n is less than 0, then we're going to break. We're going to break out of our iteration. But remember we said n is the length of nums2, not pointing to the final index. So we're going to go ahead and take n, decrement by 1. And we're going to do the same thing with m. Did I say that right? All right. So if once n's out of bounds, we're done. We're going to break out of the iteration. So next thing we're going to do is we're going to check is m out of bounds. So if m is, well, we're actually going to check if it's in bounds. So if it's greater than or equal to 0, and nums1 at m is greater than nums2 at n, that means we need to merge the number from nums1. So nums1 at our right pointer gets set, nums1 gets set to nums1 at our m pointer. Okay. Now, if it's not greater than, then it's either equal to or less than the value from nums2. And remember I said we're just going to default to using nums2. And the reason is once we're done iterating through nums2, that means that every remaining value in nums1 is less than the values in nums2. Because remember, we said if it's equal to, we're going to use the one in nums2. So like here, we would use this 2. But then once we do that and we're done with it, everything in here must be less than. So that way we don't even have to do any more comparisons because it's already been sorted in non-decreasing order. So Here, in that instance, we're going to take nums at the right pointer and set it equal to nums 2 at n. And then we would, oh, I forgot here. If we use m, right, then we need to decrement m. And if we use n, we need to decrement n. And then no matter what, we're going to decrement our while pointer. And we don't return anything. We just alter it in place. Let's see if we did all right. Name nums. Yeah. Nums 1. There we go. It's syntax. It always gets you. You know, that's the crazy thing about coding. They expect you to spell things like correctly. I mean, what's up with that? All right. So we got it. And go ahead and see here all the test cases here passed. Let's go ahead and submit. And time complexity, right? We iterated through once, so we're big O of n, time complexity. Oh, my bad. Big O of m plus n, right? Because there's 2 arrays. My mistake. And space complexity usually shows up here, but I'm not seeing it. But we don't have any additional data structures, so we'd be doing this in constant space. So I hope this was helpful to kind of explain how to go through this problem. It's not particularly difficult, but if you pay attention to the different things we used here, like our while loop, the pointers, how and when to decrement the pointers, this will be really useful when approaching other array and string type problems. So that way we can start to develop systems for solving problems rather than just trying to memorize each individual solution.